Thank you, and hi, everybody. So I'm Ben Morge. I'm the VP of Customer Success at Scality, and I'm going to present you a very interesting use case, which is the cloud storage for Splunk Data Lake. The customer is a very large bank in the US, and the need was to store about 40 petabytes of Splunk SmartStore data on 2 sites, each site fully replicated to the other one with a tolerance to up to 2 minutes for the replication to happen. And the retention of the data is 1 year. So that represents about 80 petabytes of storage after erasure coding and overhead. So this successful deployment was a strong collaboration between Splunk, HP, and Scality. So Splunk buckets, we have multiple temperatures on the Splunk buckets. And here in that case, we have 2 temperatures, so hot. This is on flash and NVMe's SSDs, so fast storage. And once the hot buckets are full, they are tiered to another temperature, which is warm. And in that case, warm is 80 servers of each 1 petabyte, composing a ring. Splunk SmartStore object storage works this way. The data is stored to the indexers. The indexers upload the data and push the data to the hot buckets that are on SSDs. So as I said, the 1 petabyte-ish flash cluster available for the indexers. And then the data is tiered to Scality RING, that is 80 servers of 1 petabyte through S3. Standard S3, Scality S3 is standard compared to AWS. And when the indexers need the data that is not available in the hot buckets, they go directly through S3, retrieve the data from the ring. And as I explained,
you mentioned that you have 1 year retention requirements.
Correct, for the data on Splunk.
Here. So when the hot tier, I guess the Splunk hot tier migrates to the ring, then the data is retained intact, immutable on the ring for another year?
Correct. So the data is stored on the ring for 1 year. So every object that is written by Splunk will stay on the ring for 1 year, and they have an automatic inside Splunk way to delete the data and after 1 year. So the deletion of the data is not made directly by Scality, but by the application Splunk in that case.
Okay. Yeah. So, are you supporting like incremental change tracking, or so you know if an object is changed at the Splunk tier, is it get replicated automatically to the ring?
So all objects are immutable because they are versioned. So every time there is a new write put of an object, we write a new version of this object that is available for get, and this new version is replicated to the other site. So all objects are immutable on the ring.
Okay.
Good. And as I explained, it's a multi-site active architecture with 2 sites in the US. So we have exactly the same architecture. We have the Splunk indexers and a cluster of hot storage. And Splunk is responsible for the replication of the indexes and the references to the objects that are stored on the ring on the lower level on Apollo servers. And Scality is in charge, software is in charge of making sure that the replication of the object is done for the data that is referenced in the indexers. And this is through cross-region replication, which is a S3 standard. So of course, this deployment, we have had a few problems. So the first one was during the migration of the data. The ingest was exceeding the firewall's throughput capabilities, resulting in replication failures. So what we put in place is an infinite replay. So an object is replayed for the replication indefinitely until the replication is successful. That helped us ensuring reliable object replication despite the network failures. The second system that we have put in place is one of the capabilities of Scality RING is, as Paul was explaining a few minutes ago, the way that we can decouple the storage from the compute from the S3 services. And if we need to grow the storage, we just have to add storage servers. But if we want to add more compute for the metadata layers, we can just add additional metadata servers. And same for the S3 stateless services. So in that case, we observed get traffic exceeding the capabilities of the servers in terms of CPU, with spikes of up to 80 gigabytes on both sides simultaneously. That means 160 gigabytes of read, gigabytes, not bits, bytes. And the SmartStore flash cache was rapidly overwhelmed, which led to all the gets ending on the ring and exceeding the CPU capabilities. So we added additional servers, we decoupled entirely the architecture, and we put one new servers with CPU, no need for NVMEs, just a bit of CPU and memory. And we can end up in what we see now. So 75 gigabytes of reads on one side. And if we added the graph of the other side, we could see the same speed and throughput. So, and 100% of the objects are replicated in less than 2 minutes. We have maintained 75 gigabytes throughput on both sides simultaneously, and we have a successful decoupled architecture, storage, compute, and S3 stateless services at a customer that has been in production for over 5 years now.
Is the tiering done at the bucket level or at the object level within a bucket?
So the replication is directly made at the metadata level. So that means all the buckets are automatically replicated and all the objects within those buckets are replicated automatically. So we have multiple ways to implement CRR at Scality. So we just say it's at the bucket level. So each bucket will have a specific configuration. In that case, it's the entire cluster is fully replicated. So all new buckets created will automatically be replicated to the other side.